Martin. So I prepared a couple of slides, and I think I'll need about 20 minutes to go through them, and I hope we'll also have some time for questions and discussion afterwards. So the title of my presentation is Increasing Trust in the Digital Infrastructure Through a National DDoS Clearinghouse. And this is basically, at SIDN at least, this is a large part of the work that we're doing, which is the ultimate goal to get the to increase the trust of people and companies and organizations in the digital infrastructure and the internet infrastructure in particular. So therefore, I think that this topic also nicely aligns with the III initiative. So as Martin already briefly touched upon, we've been seeing DDoS attacks almost, let's say, routinely on the internet, with some of them actually hitting the news, as you may remember. So we have this little map on the top left of your screen, which is the result of the DDoS attack by the Mirai botnet, which was carried out late 2016, which consisted of, at some point, of some 600,000 infected IoT devices, all carrying out an attack on a DNS operator. And as a result, this led to several outages of popular services such as Twitter and Spotify, and at least in the US, which is actually the red parts of the map you're seeing there. And the same botnet was also used to basically knock an entire country out of off the internet. I think it was Liberia somewhere. At least it was in your region, in Africa. And there were also attacks being carried out on other infrastructure, such as a hosting provider, OVH, and also on Deutsche Telekom, which is a German ISP. And the particular incident that Martin referred to was back in January 2018, when the Dutch critical infrastructure was hit by a number of DDoS attacks. And it was not only banks, but also government agencies like the Internal Revenue Services and that sort of thing. So, and this basically triggered an activity in the Netherlands to look at a better way of protecting the Dutch critical infrastructure from DDoS attacks. And this is a slide on a few trends in DDoS attacks. I was getting ahead of myself a little bit. So we spoke about the DYNE attack, which presumably was around 1 terabit per second. So that's really a lot of traffic. And we're also seeing, let's say, another trend that we're seeing in the DDoS landscape is more distributed sources like Mirai's 600K infected bots. And there's also this other botnet called HiJame, which consists of around 400K infected devices. We're seeing higher propagation rates. So the botnets can propagate really fast on the internet, let's say doubling their size in a matter of hours, for example. Attack traffic is getting more complex. There is a high churn of botnets, which means that some machines are leaving and entering the botnet, let's say, at a very high pace, which makes it really difficult to mitigate these DDoS attacks. And there are several types of DDoS traffic that these botnets emit. On top of that, these attacks are actually getting easier to launch. So the attack in the Netherlands, for example, was launched by a 16-year-old guy who bought the attack on the internet for about 40 euros, so that's around $40. And they're available through sites called stressors or DDoS as a service or DDoS for hire. So it's really easy to buy an attack and to carry it out. It's just pay and click, and it's like buying a book on Amazon, for example. And one other thing is that the attacks that we've been seeing in the previous slide, so the examples were basically direct attacks from the botnet directly to the target. But there's also a possibility that these attacks will be reflected off of other infrastructure, such as DNS open resolvers. And this other intermediate infrastructure could actually add a reflection factor, meaning that the amplification factor, which means that the attack traffic would actually increase by a number, perhaps by an order of magnitude. So there's also a risk that these DDoS attacks or that these booter services are going to make use of reflection services, which might further increase the amount of DDoS traffic that folks need to handle. So these are basically the trends that we're seeing in combination with the specific examples on the previous slide. And we're also observing that the society throughout the world, be it Africa, Europe, or the US, is increasingly dependent on network infrastructure, and in particular on the internet, of course. So we see that these DDoS attacks can have severe consequences. So this is why in the Netherlands we decided to do something about this. And the key concept is basically information sharing. And that's because the internet, as you know, is fundamentally a collaboration. It consists of about 65,000 autonomous systems, networks, if you will. And these networks need to collaborate to be able to provide the service that the networks need to be able to interoperate or to collaborate to actually provide an end-to-end service, to be able to exchange traffic from one network through other networks to the final destination of where your server sits, for example. So the internet is a collaboration, and this means that if you want to secure it, you will also need to do that collaboratively. And that's basically the key concept of what we're proposing in the Netherlands. So on the right, there's an example in this graph. It consists of, so this example shows the key concept of the initiative, and it basically shows 3 service providers, SP1, SP2, and SP3. And in this example, the SP2 is being hit by a DDoS attack. And the key concept of, let's say, our approach in the Netherlands is that SP2 creates what we call a fingerprint of the DDoS attack, which means that it describes what kind of traffic is in the DDoS attack, what protocols are being used, what are the packet lengths, what port numbers are being used, what are the source addresses. And SP2 packages this information in a DDoS fingerprint and shares the fingerprint through the clearinghouse with SP1 and SP3. So the net result is that SP2 still needs to handle the DDoS traffic because it got hit by it, so it will need to somehow handle it. But SP1 and SP3, they get information that perhaps they get information on DDoS attacks that take place elsewhere, which means that they can prepare themselves proactively should that attack come their way, okay? So for SP1 and SP3, this concept makes DDoS handling more proactive, okay? So in our, let's say, in our approach, this basically buys SP1 and SP3 time, because now they can prepare their network infrastructure for this particular DDoS attack that hasn't hit them yet, without the stress of having to do that while the DDoS attack is ongoing. So if they would not share the information, and let's say after an hour, SP1 would get hit by the DDoS attack, they would have to figure out how to reconfigure their network to handle the attack while the attack was ongoing. And that's a lot of pressure, of course. And this system basically enables SP1 and SP3 to buy them time, and as a result, configure their network so that they're prepared in case the attack comes their way. And what's important here is that what we're talking about is basically an additional layer of information sharing. So we're sharing metadata about these DDoS attacks, and it's an addition on, let's say, existing anti-DDoS services like scrubbing services, for example. So you will still need to have these scrubbing services in place, because in the example, SP2 will still need to be able to handle the DDoS attack, the attack traffic. It will need to throw it away or scrub it or clean it or whatever else. But on top of that, they're basically adding an additional layer of information sharing, okay? So this concept is basically open to all service providers in the Netherlands, although we're initially focusing on critical infrastructure. So that means financial institutions, institutions in the telecoms infrastructure and that sort of thing. And what we're also hoping is that these fingerprints are going to be able to improve attribution, and as a result, enable better prosecution of these of the perpetrators of the attacks. Okay. So the information that's being shared between these service providers are the DDoS fingerprints, and I already explained this. They consist of metadata about the attack, like domain names used, source IP addresses, and all that sort of thing. And optionally, the provider of the of the fingerprint, so SP2 on the previous slide. They can also include PCAPs, which is basically a traffic capture of the DDoS traffic, so that the other service providers can analyze that information, right? So that's SP1 and SP3 in the previous example. And they can also, let's say the provider of the fingerprint can also include other types of information, such as packet filtering rules, for example, that these other service providers would be able to use. Okay. Well, the fingerprints are basically generated from, can be generated from several types of network measurements, such as PCAPs, net flows, and all that sort of thing. That's very technical. And that's being done by a component called the dissector. So the clearinghouse basically consists of two components: a dissector that creates fingerprints based on incoming DDoS traffic, and there's the DDoS DB, the DDoS database, that basically acts as the sharing point for these fingerprints. Okay. Oh, that's basically what it says in this slide. So what you're seeing here is basically the same example again with SP1, SP2, and SP3. This is the incoming DDoS attack. So that's SP2, and they use their dissector to create a fingerprint that they can store locally in a database, but they also share the fingerprint with SP1, for example, and also with SP3. And the fingerprints are then being used by the operations teams of SP1 and SP2, and they are using it to reconfigure their network so that they're prepared for the attack, the attack coming from the red arrow, in case the red arrow also points in their direction, perhaps an hour later or something. Okay, so that's the key concept. This is the key, the overall architecture, which is a draft, so we're currently fleshing this out. So in the Netherlands, this concept was embraced by a broad coalition of different types of organizations. So that includes ISPs, banks, it includes not-for-profit DDoS protection services, it includes ministries and other government agencies, as well as existing collaborations to mitigate DDoS attacks. So, for example, we have a Dutch Continuity Board, which is a collaboration of several ISPs to collaboratively handle DDoS attacks. So that's not about the sharing of the fingerprints, but about the actual handling of the attack traffic. And similarly, we also have the NBIP NAWAS, which is a scrubbing street that a shared facility scrubbing street for hosting providers, for example, that they use to handle their DDoS traffic. Okay, so we have several working groups in the initiative that might not be that interesting to talk about today. But what's interesting as well is that the whole initiative is being supported by and facilitated by the Dutch National Cybersecurity Center. So it's really, as you can see, a national initiative with a wide range of players involved. So the status right now is actually that we have this, we basically consider two different types of tracks. The first one is what we call a technical track, which is about setting up a prototype for the prototype system that enables these different service providers to exchange the fingerprints. And that's something that we currently have in place in a prototype form. So we basically have a bucket of software that the University of Twente developed, which is a university here in the Netherlands. And it's basically the dissector and the DDoS DB. So that's the facility for exchanging these fingerprints. They developed a prototype of that, and we managed to get that to work. So that's working on a technical level. And we also connected several partners from the initiative to that system. So that's KPN, for example. They're a large ISP here in the Netherlands. It's the National Cybersecurity Center. It's SIDN and a couple of other folks. So that's all working, but we're not exchanging any fingerprints yet because we first need to go through a legal track, which is about setting up an agreement that enables parties to actually exchange these information. And this is important because the fingerprints contain IP addresses, which under European law are personally identifiable information. So there needs to be something in place, a contract that covers these kinds of things, right? And it's not only those elements, but it's also things like governance and liability that need to be part of that contract. And what's important in setting up, so we basically have a prototype technical system right now, and you could also say that we're doing a prototype legal data sharing agreement, if you will. So it's also somewhat experimental. And it's experimental because we need to take several things into account that we don't know how they're going to pan out in the future. So for example, one important dimension is that once we have this agreement in place, it needs to be able to scale to 25 different partners, right? So we only have like 7 or 8 in this small closed user group that we're using now to exchange that connects to the technical system. But the legal agreement needs to be such that it can also expand to these 25 other partners, and perhaps in the future to an even larger set. Okay, so these are actually important requirements for the legal folk to take into account. So as you can see, one of the key elements here is that it's not so much a technical exercise, but it's more of a multidisciplinary exercise, which involves both technical component, legal components, governance, and all that sort of thing. So in my opinion, that also makes this a very interesting initiative. So our short-term next steps are to run a pilot in the Netherlands, and as I already mentioned, we have the technical facilities in place, and we're now waiting for the legal folk to set up to flesh out this agreement, to sign it, and to then exchange the fingerprints. And I expect that this will happen in the next few months. So our approach there is to start small and then iteratively scale up to other partners. And at the same time, a subset of the partners involved in this initiative are also part of a project called Concordia, which is a European project. So there's European companies in there as well, so like Telecom Italia, for example, and Ericsson and that sort of thing. And what we're trying to do there is basically take the Dutch initiative and kind of try to develop a cookbook based on that initiative, and then also run the initiative in Italy, which will be led by Telecom Italia, and use their experience to further update this cookbook. And the advantage is that you then have 2 use cases where the DDoS clearinghouse has been tested and evaluated, and the experiences have been captured in the cookbook, which can then later be used by other countries in Europe or elsewhere to also set up their own DDoS clearinghouse infrastructure. Okay, so our approach is really to start small with 2 use cases and then try to scale up. And also, that's also what it says in the last bullet. So from the Netherlands, try to go to Europe and then perhaps even global, and also extend our scope to include, non-critical service providers. Okay. So, and that was basically my last slide, and a summary of the initiative, what it is and where we stand. And if you guys have any questions or feedback, then I'd be happy to talk about that. Thanks.
Questions? Thank you very much, Cristian. You came across very well, very clear, and good to see you progressing on this excellent adventure. The main challenge in all this is trust relationships.
Yeah.
And the challenge of today, I think, is to making trust scalable as well.
Yeah.
So, the old models of trust in the CERT communities, in the security communities, even in police, have been based on, I know this person, so I trust it.
Yep.
Certification has helped a little bit, and we may need to move beyond it. And this platform, one of those things that can facilitate that, I think.
Yeah, I think that actually that's spot on what you just said there. I mean, we're currently at a stage where we still rely on personal trust, as you said. So because everyone in this small user group, we all know each other. But then at some point, the scale will get so large that you will need to move to impersonal trust because you don't know everyone anymore. And that's a real challenge.
Can you speak up?
Yeah, I have a question. Cristian, can you hear me?
Can you hear the?
Yeah, I can hear you now.
Yeah.
Okay, I think okay. So it's correct. will look like. And this is a Dutch initiative being booked, and soon we will expand it to Italy and maybe to Europe. So look like that seems to be the path instead of working, for example, starting to European maybe something with Netherlands, and we think we can now share with the other European countries. But I see you will face some resistance because you look like you are exporting something. Is it so? My question is, why is that you didn't start from putting people together? I think in Europe it's easy for you guys to work together, set up like a kind of working group or something, then and develop the idea, okay, and then each country is going to implement. I want to see them.
Okay, well, I think it's two steps, and Cristian will go on that. The first step is you develop a concept and you make it work. The second part of that is how can you make that concept available to other parties by making it available to other European countries with European funding. This same model is probably useful to make it available for other countries too. That's one track. The second track is by sharing this already today, your concerns, your ideas, you can already feed back. They can think about it, and it can inspire you for your action. So it's better than not sharing at all in that way. So yes, there's not a model with hardware and software that's yet available. That will take years.
Well, but the software is actually open source, so it's available. And you can use it, but it's a prototype system right now. So, and if you really want to have, because for this to become a success, the system, you need again, it's all about trust. It's not only about trust in people, but also about trust in the software in this case, because the component that generates the fingerprints, this dissector, you need to make sure that this works properly, because otherwise ISPs are going to, or service providers are going to make the wrong decision based on wrong information. Okay, so it's not only about, let's say, people, but also about trust in the system. So this means that we're actually right at the beginning somewhere of this whole initiative, because the software that we currently have is basically it's PhD-ware. It has been developed by a PhD student at the university, and it now needs to be taken from this PhD-ware level to production level stage, so that folks can actually use it in their operations.
Maybe my question is that because you see that this is a matter of coordination, collaboration, that's why I was insisting that I thought it should be started from a certain level and it's good now to look like now we're doing like you see.
Could you repeat the question, Martin? Because I can't hear the gentleman very well.
Alain was just saying was top down or bottom up. It's really what you sketched is it's emerging and it will expand in availability.
Yep, it's really bottom up. So there's no government or anything that says, okay, you guys got to do this. They support it, and as you saw, we have the National Cybersecurity Center, which is part of the government in our consortium. But really, the initiative is coming from the operators, the universities. So really, from the bottom up.
Yep. So we got the next question from.
Cristian, just
can you introduce yourself?
Lucas Tramontosi from U.S. State Department. What entity does the consortium envision managing the clearinghouse, particularly as that kind of expands across countries?
Yeah, that's a great question. So that's something that we're struggling with right now, to be honest. So right now we're a loose collaboration of these 25 different organizations, and there is no real entity running the system. So there's no DDoS clearinghouse incorporated or something like that. So we don't have a legal entity that represents the initiative right now. And in this stage, that works because we need to get from a prototype phase to something that's more mature, and most of the folks know each other, and so that kind of works. But in the future, I expect that this will need to change, that perhaps we will need to set up a legal entity, or maybe we need to embed the work in an existing legal entity or something that has a neutral stage, a neutral reputation within the Netherlands, and that can really do the maybe the onboarding of new partners, maybe run the technical facilities and all that sort of thing. Yeah. So that's really something that we are thinking about, but we haven't really made a decision on that yet because we're in an early stage still. Yeah.
Thank you. Question, Yazid from Benin. I understood that you are drafting a document for data sharing, if I well understood. My question is, who is involved in this drafting?
Yeah. Yep. Excellent question again. Yeah. Thank you. So what we're doing right now is we basically, we also for the legal part, we took kind of an experimental approach, if you will. So what we did is we, from this small group of 8 to 9 partners that are currently connected to the technical system, but not exchanging information yet, we asked 2 of them to come up with a draft of the proposal. And we asked the legal person, a legal person from SIDN, which is the organization I work for, and a legal person of KPN, which is one of the larger ISPs in the Netherlands, to try to come up with a draft agreement. And we currently have a draft agreement, and this will then be shared within the consortium. Folks can provide feedback on that, and hopefully we'll then get to a very simple agreement that folks can easily sign, and then we can start exchanging fingerprints. So we really didn't want to start with 25 legal folks sitting in one room, because that's not we expected that this might not be the most efficient way. So instead, we also took a kind of a prototype approach there and asked 2 legal experts from 2 different partners to come up with a draft agreement, and then share that within the consortium to try to come up with something that works for everyone. And we specifically picked KPN, by the way, because they're a large ISP, so they have a lot of regulation that they need to deal with. And if they can, let's say, come up with something simple that they can live with, then this will probably also work for other partners.
You don't see it, but I see a very understanding smile and nodding from this clearly experienced gentleman.
Okay, that's good to hear. Good to hear.
So, any other questions? So, what Kevin Shaker from ISOC?
Yeah, thank you, Cristian, for the presentation. So, my question is related to the one of the 2 slides you shared about the Mirai botnet attack, which was a number of small devices connected to the internet. So, do you have any recommendations for home users who have similar devices like printers, cameras, and so on, that are connected to the internet, but are at the same time very vulnerable to being compromised? Are there best practices or documents you could point us to?
Yes, so very practical recommendations would be to change the password settings of your administrative interface of the printer you have connected, or the webcam, or whatever else. Because if you look at so there was a great paper that analyzed the Mirai botnet. It's also in this presentation somewhere. It's a great analysis of how the devices were compromised by Mirai, and how the botnet subsequently spread across these 400 to 600K vulnerable IoT devices. So there's a few things that users can actually do. Like I said, changing default passwords, making sure that devices are not necessarily exposed to the internet while this is not necessary. But on the other hand, there's also some things that they are probably unaware of. So for example, if you have an IoT device that gets a firmware update, if it gets one at all, and that firmware update introduces a new vulnerability, then we know that the Hijain botnet, for example, the botnet operators, at some point there was a new vulnerability discovered, and the botnet operators managed to make use of that vulnerability within 10 days or something. So for normal users, they can do some stuff, but when it comes to new vulnerabilities that are being introduced into IoT devices, that's much more difficult to really get that mitigated from an end user perspective. And this is also, if you're interested, so I'm also a member of the SSAC, the Security and Stability Advisory Committee, and we recently released a report on the interaction between the domain name system, the DNS ecosystem, and the IoT ecosystem, and what the challenges are from that perspective. And one of the things that we advocate there is that, let's say, fighting DDoS attacks from the IoT will take a multifaceted approach. So, for example, you will have to, as an operator, you will have to have DDoS scrubbing services available. So you need to be able to scrub DDoS traffic, or you need to be able to black hole it or whatever else. You need to have information services available. So you need to share information, for instance, through the system that we just talked about. But I think it also requires kind of more intelligent edge systems in people's homes, for example, that really discover when an IoT device is vulnerable and perhaps temporarily disconnects it from the internet. Okay, so I think that if you really want to do this, fighting IoT, insecure IoT devices will take some effort from end users, but it will also take effort from the IoT ecosystem, so IoT developers, for example, and it will, I think, also take it will also involve security systems in edge networks, as well as more advanced DDoS handling techniques for operators. So there's various elements to be able to really do something about this, in my opinion. Hope that answers your, that was a long answer. Hope it answers your question.
This afternoon we'll talk more about secure IoT, and we'll mention the spin as well. But
okay, right.
Thank you for your time. Really appreciate it.
You bet.
It's been very clear again, and yeah, enjoy the rest of your Sunday.
I will. Thanks a lot, Martin. Thanks, you guys.
So, ladies, gentlemen, it's the break. Let's continue this at 1:15, an hour from now. Jean-Pierre Routoumi and Yuri Ito, who joined us earlier this morning, and Adil will first go into the anti-abuse part. Okay, sorry, and oh, sorry for I need to run to the item in which you'll be willing to moderate this. Okay, 10 minutes? I'm sorry that I have to run the. So for lunch, at 1:15, back together with Jean-Pierre, Yuri, and Adil. Can you shortly?
Yeah, so Tarek, I think we went for Cymru. Everybody knows Cymru. It's Cymru. And they are very active in also DDoS mitigation, information sharing, and I think we knew these people from maintaining the bogus notice leaks. But now I think they are doing more stuff, and share about fighting the DDoS.
Okay, we'll go very fast. Don't worry. Okay, community tools to fight the last one is that sometimes it was sometimes used to read other kind of attack. It's like an iceberg. We see only different parts of the attack. Other part is hidden. Okay. We have multiple kind of those attacks. We have denial of service. A lot of people ask me, can one IP address put down a web server? Yes, sometimes yes. And for this example, the hacker or the bad guy used vulnerability related to Apache. Okay. This is an example or this. And this is for the others. As you can see, here is used some IoT or router or master. Okay, how to prevent and fight against this attack? I think the best one is to implement TCP38. It's really, really very old. It's about 41 years ago. Did that make sense? The TCP38. It's about 21 years ago. Yeah. And since now it's not fully implemented by ISP. Second thing is to find and to fix the occupied houses or router or that have open resolver, open DNS, open resolver, open FTP, open SNMP. And third thing, maybe you need to subscribe to Cymru program feeds to appear with us. And the last one is to use our TLS service. Okay. Google is a kind of marketing as a private or reserved IP address that we see in the advertising PGP. And those IP addresses should not be applied in NLnet. Sometimes studies show that 60% of net traffic were used Google. And this is the statistics yesterday for the IPv4 and IPv6 Googles. We have a lot of IPv6 Googles. And they are going to appear with us for Google. For TLS, TLS is kind of collaborate with ISP, with university, with the people who run PGP to minimize the gap of the DDoS attack. Okay, this example, this ISP has already established PGP session with Cymru. And we see a lot of ISP on the other side. They have might be bad people or IoT devices running in this ISP. I'm trying to attack the ISP-X to attack. What we do is to announce the attacker IP. Here I say again, I announced the attacker IP, not the bad guys, but the attacker IP to our partner to be backhauled. And after that, the attack stopped. But the thing, here the attack IP is already affected because it's down. Is it clear? You have a question? Okay, next. Here they look to about the TLS and more detail and technical detail about the TLS. Okay, that's all. Very fast.
But I have a question for
yes.
you. But it look like Team Cymru. No, it's Team Cymru. So yes. In Team Cymru, you have some free services, or some other services are based on subscriptions, or so which one? Or the one you just said?
Yeah,
the free service
for the community service.
For ETRX.
Yes.
That means all the ISP incorporate the black hole.
We have a lot of partners that are already dealing with us. So we can have partner can advertise /32.
So if a specific ISP is under attack, it will advertise the ITRS, and the ITRS will dispatch the attack to the other ISP.
Yeah.
Okay.
Then they'll block the traffic on that side.
It is a convention between them, or the ITRS is the convention.
It's a kind of cooperation between ISPs.
Any other questions? Okay, so thank you, Tarek. Welcome. We wait for lunch, and we're supposed to be back here in Pastor Watman. Project.